March 2026, the Persian Gulf. A warship cuts through black water at 40 knots. On its flight deck, a rocket booster ignites. A small delta wing aircraft punches into the sky. 8-foot wingspan, 10 feet long. A warhead that costs less than a pickup truck. Then a second one launches. A third. Within minutes, an entire swarm is airborne, heading straight into Iran's air defense network. This was the first time the United States Navy deployed a cheap, expendable attack drone in actual combat. And it happened from the deck of a ship that our own Navy tried to throw away. The literal combat ship. The media called it the Pentagon's floating garbage. The Freedom-class variant had a propulsion system that channeled 4 engines through a single combining gearbox. The torque loads exceeded what the gear teeth could handle. They ground themselves into metal dust while the ship was underway. USS Milwaukee lost propulsion on her maiden voyage. 1 month after delivery. USS Detroit, dead in the water, towed back to port. The Independence class had a different disease, a trimaran hull built entirely from aluminum. 3 hulls joined by a wide connecting deck. Aluminum saves weight, weight saves speed. But aluminum fatigues under the relentless cyclic stress of ocean waves. Structural cracks propagated through high-load junctions. A warship whose skin was tearing itself apart. The Navy decommissioned some of these ships before they reached half their design service life. Ships that never grew old enough to fight. Congress called them a waste of money. Admirals called them an embarrassment. The program was dying. And then Iran sealed the Strait of Hormuz. Here is what nobody expected. While $13 billion supercarriers sat safely in deep water, while Aegis destroyers held the outer perimeter, it was this ship, the broken one, that went inside the cage. The ship everyone wanted to scrap became the ship that changed the war. Why? Because the equation did not ask for the best ship, it asked for the right one. Look at the Strait of Hormuz, 21 nautical miles at its narrowest point, but the usable shipping lanes compressed to 4 miles, 2 in each direction. 20% of the world's crude oil passes through that keyhole every single day. Now look at what Iran built around it. Beneath the surface, thousands of naval mines, contact mines, bottom influence mines, rocket-propelled mines that sit on the seafloor and launch upward into a hull. Behind those mines, over 20 Ghadar-class submarines lurking in the acoustic clutter of the shallows. On the surface, over 1,500 fast attack craft, small fiberglass hulls capable of 50 knots. Their doctrine is saturation, enough mass to overwhelm any defense system. From the air, drone swarms filling radar scopes with hundreds of low-speed signals, and behind that electronic noise, ballistic missiles descending at Mach 3. This is not random aggression. This is a precisely engineered kill zone designed to exploit one physical constraint. The time it takes an American combat system to detect, classify, and fire is longer than the flight time of an Iranian weapon at close range. That constraint locks our supercarriers out. $100,000 tons of displacement, 5,000 sailors, $15 million per day in operating costs. You do not push that into a bathtub where the enemy has had 40 years to rig every square mile. But someone had to go in. Central Command needed a platform with 4 capabilities: a small radar signature that does not attract ballistic missiles, speed above 40 knots to outrun targeting solutions, a deck large enough to launch drones, and a displacement small enough to operate in shallow coastal waters. Run those variables against every hull in the fleet. Only one answer comes back. The Independence class provided something unexpected. 3 hulls spread apart create extreme stability. The ship resists rolling, stays flat. Irrelevant for a traditional warship. But for a platform launching drones from its deck in open ocean swells, it is everything. And those failed swappable mission modules that Congress criticized, when you strip them out, what remains is a massive empty flight deck. 11,000 square feet of unobstructed surface area, the footprint of 3 tennis courts. That empty deck was not designed to be a feature, It was left behind by failure, and failure sometimes leaves behind exactly what you need. The weapon they put on that deck was called Lucas, Low-Cost Unmanned Combat Attack System. An engineering paradox, its airframe is reverse-engineered from Iran's own Shahed 136, one of the most effective one-way attack drones in modern warfare. American engineers studied what made it effective, kept the physics that worked, and rebuilt everything else. Then they flew it back to the country that designed it. Each Lucas cost $35,000. An SM-6 interceptor to shoot it down cost nearly $5 million. Iran spent 40 years building a toll booth that charges $5 million per car. Lucas drives a $35,000 motorcycle right through the barrier. The cost trap that Iran designed to drain American interceptors now works in reverse. When Operation Epic Fury commenced, Lucas drones launched from LCS flight deck struck command and control nodes. They hit early warning radars. They struck missile launch sites. They hit military airfields. The expendable drones did not kill the hardened targets. They blinded the air defense protecting them. Behind the swarm, Arleigh Burke destroyers opened their vertical launch cells. Tomahawk cruise missiles flew through the corridors that Lucas had just opened. Simultaneously, other LCS platforms deployed unmanned mine hunting systems into the strait. Robotic boats towing sonar through suspected mine zones. Helicopters dropping underwater robots that swim to mines and destroy them. 3 layers of detection, 0 sailors in the water. The results wrote themselves across the surface of the Persian Gulf. Iris Jamaran, one of Iran's most capable frigates, struck and sunk at Bandar Abbas. 3 warships destroyed without leaving port. Iran's homemade drone carrier, the Shahed Bagheri, structurally destroyed at her berth before she ever sailed into combat. Over 100 Iranian naval vessels were destroyed. The surface fleet that was supposed to swarm and overwhelm us ceased to exist as a coherent fighting force. The engineers did not fix the cracked hull. They did not repair the failed modules. They ran the equation again, and the failures became the features. The empty deck became a drone launch pad. The trimaran hull that cracked provided the stability that rocket-assisted launch demands. The low cost that Congress complained about became the acceptable risk that let commanders push LCS into the teeth of Iran's defenses. The littoral combat ship was never a good ship. It was the right variable, and the equation worked.